Hello everyone! In this tutorial I want to show you how you can visualize your astrophotography data a little bit differently so that you can essentially detect easily moving things in the sky. So I'll first show you a little bit the theory and then move into a practical session. So normally for deep space photography you take a series of images, 10, 20, 30, 100, could be also varying in the exposure time. And then in principle, what you do is you calibrate, try to remove all the noise, align and stack them, and then process the final picture to bring out all the detail and have a great astrophotography. I mean, now we are not interested in that. We want to do something different. We want to inspect quickly all the captured images against time. Like if you could see an animation of all the frames you captured, a little bit stretched, and you can control the flow of the animation, and this way enabling you to detect easily moving objects. You're gonna see later in practice how this works, but this is what we want to do now. So what we want to do is we want an easy way to basically stretch and animate all the frames. We want to see them in full resolution. So if you have a huge sensor like 20 megapixels and your monitor is an HD, has HD resolution, we don't want to see a resized version of the video. We want to see parts of the video in its full resolution on the monitor. And of course we want it to be easy so that we don't spend ages trying to do this. And moving things, what do I mean about detecting moving things? Now this could be fast satellites passing by or planes. Okay, interesting, maybe not interesting. It could be slow moving satellites or spacecraft. Also could be distant planets like Uranus or Neptune, and you could plan specific sessions for that to image them in different nights, or even in one night. I believe that you can see Uranus or Neptune moving against the star background. And it could be also comets or asteroids. So this is what I mean in detecting moving things in your images. So what's the practical solution to achieve all of that? First, we want to calibrate and align all of our images like we would do, let's say, for a normal astrophotography processing session. And for this, I prefer Deep Sky Stacker, but it could be in principle any software that can calibrate and align and debayer if you use a color camera all day. Then we want to stretch these images we produced, all the calibrated ones, and create an animation out of them. My preference for that is to use PIPP, the Planetary Image Preprocessor. Normally PIPP is used for planetary imaging, but in this case we want actually from all these images to automatically stretch them a little bit and produce a video, and PIPP is just great to do this. And the final step, we have the video. We want a nice video player software that can do some processing on the fly and can easily navigate back and forth to see the video, as we said, in its full resolution. And for that, I prefer the SER player, which apparently is made from the same team or developer that does PIPP, and it's able to crop. Why I really like a SER player is because you can see the video in full resolution, so you can select a part of the video and show it in 1:1 resolution on your monitor, and this is great. This is what was stopping me in the past from doing this easily. And of course it has on-the-fly stretch, intuitive controls, and good performance. So SER is the choice, my choice for that. Now, in principle, what we're doing is we have the raw images. We use Deep Sky Stacker to produce a set of calibrated and aligned, and as we said, debayered also if you have a color camera images. Then we take these aligned images and import them into PIPP, where we stretch them a little bit and produce an animation. And then we use the SER player to inspect essentially the data and stretch it a little bit more. So now I'm going to move in a practical session to show you all of this in practice. Okay, so we'll start with Deep Sky Stacker, and we do basically all the steps that we would do as if we wanted to process our pictures. So I'm gonna just select all the lights. So in this case, it's 120 1-minute lights of M31. All of them, okay, the darks. I mean, all the normal things that you would do if you have darks, flats, all these things, and the dark flats. And now here come the important settings. So here now you must go in the stacking parameters and say here on intermediate files, you must have this checked, because this is what we want to do. We're not interested for the stack. We are just interested for these intermediate files. And here we say to Deep Sky Stacker to save each registered and calibrated file. So, okay, you have this checked. Here the format doesn't really matter, but I use fits. And for the rest, I mean, I would say just use simple settings for at least for the lights, because we're not interested for the stack. So you might as well just use a quick stacking setting. So, and another setting important here, I say no background calibration, because I want to see the data as it is. I don't want Deep Sky Stacker to essentially align the background in all the frames so that it matches. I just want to see the calibrated and registered files as they are. So no background calibration. And we hit go. So fast forward and the stacking is done. As I said, we're not interested really for the stack. We're interested for all the intermediate pictures, the calibrated, aligned, registered, and debayered intermediate pictures. And we're gonna just import them to PIPP now. So I'll bring PIPP here. Let's add this. So we are here. It's all these .reg files that Registax produce. So I'll select all of them. Yes. Now just make sure that they are in the right order, because the animation is going to be created based on the order that the files are here. Usually if you sort them by file name, it should be okay. Now I want to see one thing we want to do here in PIPP is we want to brighten the image a little bit. We want to brighten all the frames. So you go into the processing options and increase the gain, and then press the test options tab, and you can see what would be the result. I'll increase the size of the picture, a little bit more to see how it looks. And yeah, this looks okay. We don't want to overdo it now, because we're gonna do it again at the next step with the SERP layer. So this is good enough. Now output options. Here use SER, because we want the uncompressed video, and all the other settings should be okay. So I'll just click start processing. So now it will take all these 120 images and create an animation out of them, automatically applying the processing that I did. Now also one detail here, you can see the resolution of the video is going to be 2500 pixels times 1600 pixels. So the video is ready. And this is because my DSLR, so I took these images with my DSLR, and in Deep Sky Stacker I use this super pixel mode. So in principle the resolution is half on each dimension. Okay, so we have our animation, we have our video, and I'm gonna open it with a SERP layer. Let's close PIPP. So now we have opened the video with the SERP layer, and it's already started playing. I'm just gonna stop it. The first thing I want to do is see the video in its full resolution, because now it's resized to fit the monitor. So I'll go to the processing tab, and this is one great feature about this player, that you can select a subpart of the video and show it in its full resolution. This is really, really great. So I'll just select an area that I know fits, so this resolution fits natively into the monitor, and it's roughly one quarter of the frame. So I'm just going to use that. Accept. And now I'm going to stretch it a little bit more. In the end, we want to detect things, so we should stretch it. Maybe reduce a little bit the gain to have maybe a bit more contrast, but yeah, I think this looks okay. And now here comes the nice part. So now I'm just gonna use this control here to move backwards and forwards and try to detect moving things. So yeah, okay, here little things passing by, look like satellites, maybe planes. This is the principle. I mean, this is just a demo to show you what you would do. Okay, another one here. You can see something else, satellite likely passing by. But some dancing hot pixels. So let's move to another part. So now I'll move into that part of the video. Accept, and I'll do the same. You can see here a dancing hot red pixel. It's dancing like that because of dithering. So when you use guiding and you use dithering, I mean, this is what it does. It jumps left and right so that you don't have the fixed noise always in the same place from your DSLR. Okay, so this looks yeah, I mean, you get the idea. Is you go back and forth to inspect to see if something is moving. Here something's passed by. Maybe it's a plane because I see here also a little light. I mean, this is not really interesting. I mean, it's nice to capture satellites. What we're gonna do is just look at the data now. I'm gonna show you a nice example afterwards, which was quite nice and useful. Some satellites passing by again. So I'm gonna move in a different area. Bottom left, yep. Let's see here, anything else happening? Same satellites, yes, yeah, or plane. Looks like a bright satellites. And finally I'll go to the last part. Yeah. So now I want to show you an example where this technique was really useful for me. Some time ago, back in May, I tried to image the integral spacecraft. And at the time, afterwards, okay, I programmed the telescope. I went to sleep. And at some point after, okay, my plan was to image some targets. And then at some point go to a specific location where I knew this integral spacecraft is going to pass by and just take images, hoping to capture it. Afterwards, I inspected the data and I couldn't see it. So I just opened each image individually. I brightened it. I compared. I went back and forth with a few images, and I couldn't really see it. So I said, okay, tough luck. I tried. I didn't capture it. But now I applied this technique there, and I actually could see it. So I want to show you as well. Let me open the right file. So I just did the same. I just processed exactly the same way as now these frames. So this was from this is a video from a much smaller camera. So the native resolution is quite is a bit smaller. So I'll just stop it and I'll just go again. I'll do the same things, processing. So let's, oops, maybe it's too extreme bright. Just reduce, so I increase a little bit the contrast and then we can see what's going on. Okay, so let's see. Exactly here. So you can see it moving here. So this is integral. And here you can clearly see it. And back then I actually completely missed it. I thought I didn't capture it. So This just shows you how intuitive is this technique. So you just have the video, you go back and forth, and you can immediately detect moving things like that, like this one here. So I hope this was useful to you, and thanks for watching.